Last week, I decided I was finally going to learn how to cook a proper beef Wellington. But, like, imagine if before I could even chop an onion or, sear the meat, the instructor just hands me a toolbox and tells me to go plumb the kitchen sink.
Right, and wire the oven while you're at it?
Exactly. I mean, I'd never learn to cook. I'd just be a terrible plumber. And that is exactly the frustrating hurdle AI developers hit when trying to train coding models.
Yeah, because if an AI model is spending all its computational power trying to figure out a broken package manager or like a missing dependency, it's not actually learning how to code.
Right. So instead of training on Python or whatever, the model is burning millions of parameters just trying to get the environment to run.
I don't know.
Which brings us to today's deep dive into a really fascinating May 2026 research post from Cursor on Composer Autoinstall.
It's such an ingenious system.
It really is. And, before we get into it, if you are inspired by this kind of AI automation and you need help uncovering where AI agents can make the most impact for your business, you should really check out embersilk.com.
Oh, definitely.
Yeah, they are today's sponsor, and they help with everything from AI training to integration and software development. So check out embersilk.com for your AI needs. But getting back to Cursor, how exactly do they stop their models from acting like frustrated plumbers?
So it really comes down to automating the setup.
Hmm.
Like when you're training a coding model using reinforcement learning, the AI absolutely needs a runnable environment. It requires that feedback loop of execution.
Like trying the code, seeing if it compiles, and adjusting, like paying an expensive tutor, but you spend the whole hour just looking for your textbook.
Right, exactly. But doing that manually across thousands of unique, messy code bases is physically impossible.
Yeah.
You would spend lifetimes just configuring files.
But wait, shouldn't human developers just, I don't know, ensure these training environments work perfectly from the start?
In a perfect world, sure, but at scale, across thousands of diverse repositories. No way. So Cursor used their older model, Composer 1.5, to automatically build the training environments for the new model, Composer 2.
Wait, the older AI builds the classroom for the newer one. How does it actually do that without a human stepping in to fix the inevitable bugs?
It uses this two-stage bootstrapping process. First is goal setting. An agent scans the target code base, it checks the readmes, the make files, and it proposes 10 setup commands.
Okay, and I assume it predicts what the successful output should look like.
Yep, exactly. Then a second agent takes 3 of those commands and actually tries to execute them.
And when things inevitably break, because, it's software.
That is where the second agent gets really creative. It actively problem solves. It'll mock missing files or create placeholder database tables or even spin up gummy Docker containers just to force the code to run.
Wait, really? It just fakes them?
Yeah, and it loops up to 5 times if it hits an error, just trying new workarounds.
Hold on, if we're generating fake tables and dummy containers just to pass a setup test, aren't we training the new model in a completely, hallucinated environment? It sounds like building a movie set where the doors don't actually lead anywhere.
It does sound counterintuitive, I'll give you that. But think about what the reinforcement learning model actually needs here. It doesn't care about the real data in the database.
Oh, so it just needs the underlying logic to compile.
Right, it just needs to execute, so it gets that reward signal for writing correct code syntax. The movie set is all it needs to practice the actual mechanics of coding.
Okay, so the structural feedback is there, even if the data isn't. But, I mean, does this actually work on a genuinely messy project out in the wild?
Oh, it does. They tested this on the Silo Monorepo, which is this really large blockchain project with pretty sparse documentation.
A total nightmare to set up, basically.
Exactly. And the AI realized it was missing a dependency called Foundry. But it didn't just fake it. It actively searched the live web, read the Foundry docs, saw it needed authentication, and then created a localized mock user just to successfully run the app.
Wait, so it's dynamically patching the environment on the fly using the internet?
Yes. And the benchmark results show exactly why this matters. Because Composer 1.5 could set up these environments so effectively, Composer 2 jumped to a 61.7% score on TerminalBench.
Wow. And that's the benchmark for configuring developer environments, right?
Yep, and that score is a huge leap from the older model's 47.9%.
That is just such a brilliant positive feedback loop. Like older generation clears the brush, paving a wider, faster road for the next generation to learn on. It actually reminds me a lot of Demis Hassabis recently winning the Nobel Prize for using AI to predict protein structures.
Oh, absolutely. He sees AI as this incredible tool that will help scientists make even more discoveries in the years to come.
Right. By having AI pave the way for its successors, we're removing all these tedious roadblocks. It's so inspiring.
It really is. Just imagine the unprecedented scientific and creative breakthroughs humanity will achieve when AI models handle their own run management and data pre-processing. We won't be bogged down by the setup.
We get to just walk into the kitchen and start cooking the big ideas. I love that. Well, if you enjoy this deep dive, please subscribe to the show. And hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.